Okay, now we will continue with the second presenter, Ms. Nur Aini Iswati Hasana, who will present about economic valuation of SRI Paddy, or System of Rice Intensification Paddy. And Ms. Nur Aini Iswati Hasana works at Department of Environmental Engineering University Islam Indonesia in Yogyakarta. So please, Ms. Nur Aini Iswati, present your paper.
Thank you. From an economic perspective, rice is an important crop, and the system of rice intensification is one of rice production technology that has been known that has a high economic value. Today, I'm Aini from Universitas Islam Indonesia, would like to present economic valuation of SRI Paddy. So, the globally safe intensification has successfully increasing the yield and the level of water conservation and also farm revenue, while in the same time it could lower the greenhouse gas emission. It could happen because of differentiation of management practice in land, water, and also nutrient. In Indonesia, the water management practice that farmers get used to do is they try to manage a certain water level to keep the soil moisture and preserve better air for the roots one. Especially in West Java area, the farmer use water level between +2 to -10 centimeter from the soil surface. However, if they apply different level of water, it could be there is a different biophysical condition, that means different yield, different water that they use, and different greenhouse gas that may be occur. Therefore, a simple economic analysis is needed to know, to determine the economic value of the cultivation that use different water level treatment. And in here, we also want to know the best value that maybe we get if we conduct the best optimum water level. So in here we use TEV, or total economic value framework. In here to do the economic valuation, this approach is really applicable in the paddy field area, and we use it because we see paddy field as an ecosystem good and also survives that has beneficial from nature to the human. And in here, when we conduct the assessment, that means a farmer could easily know the value that might be they have if they applied a certain water level, and farmers' skepticism on the system of rice intensification method or uncoding method can also be addressed. So Ciherang SP was cultivated in one cultivation season using pot. We use pot because we want to know the precise amount of each TEV parameter, and also we use merit top in here. So it's not only for the reservoir, but we want to maintain the water level in here using the merit top. We have several set point of water level in here from -12 to +2 centimeter from the soil surface. This is the water and nutrient management that we use. This is actually the intermittent irrigation management. We also have several sensors to measure several parameters such as precipitation, soil moisture, and also air temperature. So this is the equation of the TEV, or total economic valuation. If we want to use this approach, we should know first the economic surface that we use and the type of value that we want to assess. So in here, the paddy field, they have two kind of value, the non-use value and use value. The example of non-use value, it's like the aesthetic of the paddy field, but we didn't account this kind of value in this study. We focus in the use value. Let's see in here, this is the equation of the TEV value. we have direct value. It can be seen from the yield that we get, so it's related with the value of the yield, and this is the cost related to the water irrigation that we use. And in indirect use value, it's related with the greenhouse gas emission because there is emission reduction in here. Let's take a look in detail. In irrigation water, we need to gather the amount of irrigation that we use daily, and then this is the price of water that we use. This is especially for the West Java area, and this is in the yield data. We don't have the yield data, then we try to estimate it using this equation by use our productive tiller number data. And for the price, we use the peraturan menteri perdagangan. And in the greenhouse gas emission, in here we use several data from the previous research from the SRI that use several water table application, and also for the conventional. So we compare the emission that occur from both treatment, and then we can know the emission reduction. Then after we know the emission reduction, we can calculate it using the carbon credit mechanism. And the price of the carbon credit, we use the standard from the New Zealand ETS. So after we know the total economic value in here, we try to find out the mathematical equation that could describe our data in here. The X is the water table that applied in the field, and the Y is the total economic value. We use table curve 2D. This is a fitting data software that we use. And after we get the objective function, we'll try to optimize it using Excel solver. Therefore, we can get the best water level in the optimum TEV value. So this is our result related to the irrigation. So we can see in here different application of water level means different soil moisture, different soil temperature that related with different crop evapotranspiration in the red bar. And because we conduct this cultivation in the same area, they have the same amount of precipitation. Even though the precipitation is more than evapotranspiration, but at that time there are several big or heavy rainfall that occur. If so, even though the climate water budget is positive, the irrigation still needed. It's around 40 to 63% of water demand, and some of it evapotranspirated. If we can see in here, higher water level usually tended to have a higher water consumption and water demand. And if we compare with the conventional one, it still has the potential to save water while lifting the paddy output. Let's see in the yield. In the application of water level that are really different, they might have unsaturated condition that also different. Different air means different oxygen means different biomass. In the biomass, we have yield, root, and also of the paddy. The highest yield occur in the -5 treatment in here. Meanwhile, in the roots, we can see in here, the higher water level means the less root domination. So we can see in here, in the less water level application, they have high root domination, heavy root in here. It means they already escaped the drought and able to regulate their growth. Except in first 2 centimeter treatment, it might be there is iron seam that formed in this treatment. And overall, if we can see in here, the yield in SRI actually is almost double compared with the conventional yield. This is the greenhouse gas emission. So this one is the emission factor from the conventional. So kilogram carbon dioxide equal carbon dioxide per kilogram yield. Meanwhile, this from the SRI. So we can see in here the last greenhouse gas emission occur in the -5 treatment. So if we can see it even less, more than 150% compared to the conventional emission factor. So after we know the irrigation, the amount of irrigation that we use, and then the yield that maybe we can gather, and also the carbon credit from the emission reduction. So we can calculate the total economic value. It can be seen in here, the blue one. And we transform it to this graph. So the dot means the TEV data, and we try to find out the mathematical equation to describe this data. So we get this equation. The equation has a square of 99%, which is very good. So after we optimize this objective function, we can get the optimum water level is around minus 5.88 centimeter. And if we use this value, we can get the total economical value of 9.708 million rupiah per hectare. So from this research or this study, we can understand that if we applied minus 5 centimeter from the soil surface, that means we could get the highest yield, and also we could reduce the gas emission as less as possible compared with the conventional one and compared with another water level treatment. But if we lowering again 0.88 centimeter from that point, we could make it reach optimum condition to get the highest economical value. And it might be hard if we could want to maintain this water level in the field, but however, this study proved that optimum economical value of SRI paddy can be addressed successfully by lowering the water level in the field. Thank you. I'm sorry, Mom, you're still in mute condition.
Thank you for the presentation, and we will start with the question.
Yes.
So the first question is from Mr. Satya Cahya Noviandi.
Oh, I see.
So the question is the SRI irrigation method suitable for sloping or steep land condition? So please answer this question, please.
Yep. In system of rice identification, the key point is keeping the soil in unsaturated condition, but still moisture enough to serve the good root zone for the paddy growth. And in the sloping condition, we might need to make kind of engineering approach, like we make kind of terracing. I'm sorry, I don't know the English version of it, but at least if we can cut the slope, we could be easily maintain the level in the field if we could do that. Thank you.
Okay, thank you. And then the second one, the second question is from Mr. Momon Sodik Imanuddin. The question is, what kind of soil texture and how much groundwater contribution approximately? That is the question.
How much, what?
How much groundwater contribution approximately?
Okay, thank you. So in here, in the study, we use silty loam soil, but if we talk about the groundwater, because we conduct it in the pot, we didn't measure, and we try to make it similar to zero because it's just a closed system in the study.
And the next question is from me. Do you think is the result in cultivate in the pot will be the same if you cultivate on field?
Yeah, thank you. That's a good question. Of course, it will be different if we conduct it in the field because there are so many components of the output, such as they might be seepage, they might be runoff, that we try to minimize in this pot or laboratory research. But at least we can get the approach in here, we can get the conclusion in here that this technology actually is having a good thing that could be applied in the field, even though we might still need to try it in the field if we want to make sure the TEV value of the field condition.
Yes, because I saw nearly the same result between the -5 and -7. So maybe we need the further research.
Thank you.
Okay, so we still have for one question. Is there any question? There is no question anymore.
Okay, may I have one?
Okay.
One more, please.
Please.
Yes. Thank you. What do you think -5 and -7 water table you set up in the plot? It is assuming that it is the groundwater table in the field. Can you explain that?
So -5 and -7 in this study means the level of water level. It means if we measure from the soil surface, it could be 2 centimeter difference between the -5 and -7. But in this study, we get a different, pretty much different condition in the result of -5 and -7, because if we take a look at a detailed data, the tiller production in the -7, even though it can survive in dry condition, but it's pretty late, the tiller formation compared with the -5. And that makes a pretty big difference between these two. But however, in the field, if we might, we still need to conduct a further experiment to really make sure what's the difference between these two. Thank you.
Okay.
Okay, thank you.
Thank you very much. So I think the time is up. Thank you once again, and we will give a big applause for Miss Aini.